Yeah, welcome back. So clearly, you know that we've talked about our gamma ray log. So what can you say about this log now? This is 0, this is 200. You can see the stick line, okay? That's what will be your middle between 0 and 200. I need already counting, right? 20, 40, 60, 80, 100, okay? They haven't used stick lines to represent it. So in this log now, at what point do we have our sand? So our sand will be here, Abi. Thank you. That's where our sand will be. Okay, and these regions are where your shield will be. Okay. So for this interpretation, awesome. Now let's move to the what we're going to do for today, which is resistivity qualitative interpretation. So what is resistivity log and what does it tell us? Gamma ray log tells us about the lithology, way to differentiate between lithology. Can we know where the shale is? Yes, we know now. We know where sand is. Good. So if we're given a log, it can sound like a petrophysicist. So if we have the resistivity logging, what does it tell us? That's the first thing. So resistivity logs tells us about the resistivity log. The resistivity log tells us about fluid content, fluid what? Content, fluid content. Specifically, it tells us about what? Fluid content. Either what is present in my reservoir, fluid content in my reservoir. Yeah, you might have heard me say reservoir. Sandstone is the reservoir that we know. Okay, it's reservoir should have a good, should be porous and also permeable. So that's the quality of the reservoir. And sandstone shows that very well. Okay, shale is not that permeable. Okay, okay, but shale is porous. Okay, but it's not as permeable as sandstone. Okay, so the reservoir is where you get. That's where your petroleum are being stored before they are being drilled and make for economic use importance. Okay, so let's move into what I'm saying before I drift. So resistivity log about fluid content in my reservoir. It tells about fluid content. What am I fluid content? Good. If, for example, you get a table water, what do you expect to be there? Should be water, right? But that's the issue. In the subsurface, different things can be there. Are you with me? So in a lithology, very reservoir is not just only one thing that is there. Just imagine you can you can buy table water and you find out that what when you are done with almost half of the bottle, you saw Pepsi remaining or soft drink liquid remaining inside it. So something like this. So you have this bottle, you know it's not possible, right? Yet it will have mixed together like mixture. But let's say it can happen. Here will just be water, and here will be like drink, let's say malt, let's say malt. So when you are done reaching this place, you see this. Okay, well, that's not really what happened in real life. Okay, so let's move over to our log. So this is our log. It tells us about the fluid content. So qualitatively, we're going to do an interpretation in this part of the video. And in the next video, we're going to do quantitative analysis of it because it is very, very important. Okay, so quantitatively, what can you say, and where do we know that? So in the resistivity, we focus on our reservoir, not on the shale. Okay, you know, here is an eye this thing, Abby. So this is shale, this is shale. So it tells us that this all of these are telling us like they are interpreting the same ball. This composite log they are for the same ball. So here we have this guy, we have this guy. So here this guy is talking about the fluid content of this guy here, of the shale. Here is talking about the fluid content of the sand. Okay, why he's talking about the fluid content of the shale. Again, so that is what it's telling us. So, but how do we tell between when it's high, when it's low? The same way we talk about high API, this and that. So resistivity, I don't know resistivity unit is in what? In ohm meter, right? Okay, good. So let me just give you a good overview of resistivity. So the fluid that we expect in a reservoir are three things. Okay, so in resistivity log, we are not concerned about the type of hydrocarbon that is here. Resistivity doesn't help us to differentiate between the type of fluid content or type of hydrocarbon. It helps us differentiate between fluid content, but it can help us differentiate between hydrocarbon. That means you cannot tell if it is gas that is there or if it is like normal petrol liquid, okay, or oil. So it's oil I want to mention. Okay, so if it is oil or gas, resistivity just termed everything as what? Hydrocarbon. Okay, good. Hydrocarbon. Okay, that's what resistivity sees. Resistivity sees everything as what? Hydrocarbon. So, and water. So the fluid content that you can beat your chest and interpret are just telling us that hydrocarbon is here, water is there. So if I give a log, you should tell us that, oh, this is where hydrocarbon is, this is where water is. This is what this place is telling us in the reservoir. So our focus in this interpretation is year to year. Okay, so now if you look at this stuff, where is the top of this reservoir? Can you see the moment where the shale region started decreasing, Abi? So this is the top, this is your top of the reservoir. Can you see? That's your top. This point here. This is your top of the reservoir. Okay? And this is your bottom of the reservoir. Bottom of the reservoir. That's the top and that's the bottom of the reservoir. Okay, so inside that place, we're going to correlate with this guy here. Top, bottom. Okay? Okay? Top and bottom. So now that's your top and that's your bottom in this place. So from here, you know where the top and bottom is on your resistivity. So just like a straight line with a ruler you can get that. Okay, this is your top and this is your bottom. Good. Now for resistivity logging, so how do we know if something is resistive? How do we know if it's not resistive? We know very clearly that water itself, is it resistive? Does water resist electricity? Does it resist current? No. We know that water, especially the kind of water that we have in subsurface, which contains of minerals, yeah, that water is conductive. Yeah, it's conductive. Most times they are actually saline safe. Very well. So they are very, very conductive, which means they have low, which that is, they have low resistivity. Good. While hydrocarbons, they are not what? They have low conductivity. They are very highly resistive. They are highly what? Resistive. They are highly resistive. Let me just give you an hint of what I know. Okay, so you know that either resistivity cannot tell us if it's oil and gas, but let's just say we have gas there. You know that air is a mixture of gases, okay, from basic chemistry. So if you have gas, for example, if you try to put a wire in the gas, like on your air, just air, will somebody feel shocked in that same room? If another person in that same room, another person will be shocked if you have a naked wire connected to the air. No, because the gas is highly, highly resistive. I think with oil, nobody gets shocked because of oil. Okay, so that is that. Just mind my shock word and let's continue. So we know that when we are and we are dealing with resistivity log. So high resistivity tells us that what we have what hydrocarbon in our what reservoir. Our focus, remember, our focus for qualitative interpretation of resistivity log is our what reservoir. So in your reservoir, you will tell that at what point do we have hydrocarbon. So you can see this guy is very high. This from year to year, I know it's increasing from 0.2 to 2,000. This 2K means 2,000. Or 0.2 to 2,000. So that's what we're seeing here. Okay. So yeah. So for me, this increase, can you see, is very, very low in this place. Then it started increasing, which means this point to this point, you should have what? Hydrocarbon. Okay. Why from this point to this point should be your water. From this point to this point in your reservoir should be your what? Water. So that's where water is. This is where hydrocarbon is. So that will come to the end of our qualitative interpretation. Thank you for listening and ensure you subscribe and like my videos. Thank you.